key concepts in confidential data management, which is sort of everything that we cover in this project. So probably some of this is going to be redundant, too simple, etc. But hopefully I can make it amusing. And part of these materials are available on my website. I teach a short course on this, and we're converting it over to edX content as well. So no need to scribble things down. So you probably don't need this, but one of the motivations is that it's easy to leak private information. We've got Tanya's work on date and zip code and gender and how that can be a unique fingerprint, assuming you've got a catalog of all that information for everyone else. Things like predictive results on social security numbers. So if I know what your birthplace is and your birth date is, then I can guess part of your social security number. And actually I can guess the first part, and since we usually hand out the last digits, that makes it extremely convenient because I probably have those for other reasons. Tables and graphs can be identifying. This is from New England Journal of Medicine, where they didn't actually re-identify people. They just, because they didn't want to find particular people, but they simulated it, and they went through the last 4 or 5 years of graphs in medical journals and said, can we spot the sick people? And yeah, they were unique. The dots were close enough to indications where there were probably only 1 or 2 people who were candidates for that disease. So although no person was actually linked, the potential for linking tens of thousands of people in the medical literature was there. And people have been identified through movie rankings, search strings, movement patterns, shopping habits, writing style, all sorts of stuff. So some concepts and terminology, and forgive me if this is too simplified, but my latest challenge was trying to explain this to UN policymakers, both field workers and program managers in UN. So I had to use pictures. Beware that this terminology varies from discipline to discipline. Right? So these may overlap, but it's useful at least to keep some of these concepts straight or distinguish between them conceptually, but don't rely on the literature to use these terms in an exact way. So often privacy is you can think, one way of thinking about that, partitioning it, is the control over the extent and circumstances of learning about people. So really, from that framework, and that's from sort of IRB, human subjects framework, it's about interaction with people and their control over the context of that interaction. Not about how you manage their information, right, and what leaks out. Now, in some areas, we'd say privacy is this whole thing, and that's fine, but just keep that as a separate concept in mind, that sort of interaction phase, versus how that information is, once it's collected, is disclosed. And that's where a lot of what we're talking about focuses. 2 other concepts we talk about a lot are sort of identifiability, which is, given some set of information, what can we learn about individuals from it? And sensitivity, which is a very high-level summary of the possibility for harm. If you were to, there's a breach of confidentiality and you were to learn something about an individual, then what happens? And there's a lot packed up in there. There are threat models packed up in there. I'm sure you've heard a lot about differential privacy, and we'll learn a lot more. In the general literature, there are different views of identifiability. And the most basic is, where is Waldo? Right, so can we find a person in a database? Wherefore art thou, record 2963874? Right? And the statistical disclosure control literature, 80s, 90s, etc., this is also known as record linkage, and sort of implicitly embedded in a lot of laws. If you can't find that person, then you're safe, which we know is not true, but it's one of those concepts that's embedded in a lot of the work. Another is around indistinguishability, which is sort of hiding in a crowd of observations. And the most well-known example of that is canonymity, where you're indistinguishable from other records based on predefined quasi-identifying characteristics. So we assume that there's some things that people can see externally, some auxiliary information, and there's some things that they can't. And then we make sure that based on that observable, assumed to be observable auxiliary information, there are a cluster of records that all look the same on those attributes. And if they're unique in the data set, then we fuzz it until, and this, this is another concept. But that intersection, that you may be indistinguishable from a group of others, but that group that you're indistinguishable still might have interesting characteristics. So indistinguishability by itself doesn't prevent learning. Right? You could learn that people were in this intersection of being arrested, committed, and convicted. You don't know which records are which. So indistinguishability is often paired with things like heterogeneity variance on what are deemed the sensitive characteristics. It's less systematic. Things like L diversity and others use that sort of approach. And then there's the concept of privacy as learning, which differential privacy is the sort of main thread, but that's the question of what can an adversary learn from this? How do we characterize that based on the background knowledge, the adversary's power? Sensitivity is not so well defined, but there's an idea that there are different types of harms that could arise from disclosures. And that the harms might have different probabilities of manifesting if the data were released, even if someone was identified or you learned about someone. That doesn't mean a harm has occurred, right? Some other things have to happen for the harm to occur. And so if that's very likely, you might think the information is more sensitive because of that. If the harm is severe, that might make you might deem it more sensitive information. If the harm affects a lot of people, that also may be more sensitive. And there are different, when we talk about harm happens to someone, right? So mostly we're interested about harm to the individual who is the subject of the data collection. What harm would come from them from their participation in this data collection event, right? Their election. But sometimes we're interested in other things, like they may be a member of a group that, a minority group, and there's law and ethics that places weight on protecting group effects. You may be interested on the effect on society as a whole. Surveillance is not, we talk about the harms of surveillance not just in individual terms of the data subject, right? Well, what that does to our entire system. And also, you'll find that institutional harms matter. Right? And so when you start to look at the law and regulations, controls, think, why does Harvard treat anything with medical information, even cold, at level 4, and anything that's social science, or lots of things that are social science at level 3? Well, that's because there's a breach reporting requirement, more or less, right? There's a different institutional implication. And so we have things from, on the top, it's minimal risk of embarrassment, things you get in daily life. These are just rough anchoring points to somebody is probably going to try to kill you, right? And somewhere in between we could argue about the different cutoffs. I would also note that in this, in this literature, we tend to worry a lot about these harms. But if you start looking at the literature on dual-use technologies and the debates about controlling information to sequencing the flu, this harm of one person being targeted, which we tend to be really worried about, is not a cause for suppression of articles and other things in scientific debates. Right? So for dual use, especially where we're talking about basic research, they're talking about pandemics as the harm point here. Right? So calibrate sensitivity with respect to the field, with respect to what things are what benefits you're creating. And just a legal note, you get this already, but laws define all these things differently, right? So there are different legal regimes. They define what it means to be identifiable differently. They define the criteria for what's harmful implicitly differently, and their scope differs as well. And we talk about some of them, but there are a lot, and not all of the information that that institutions worry about is strictly about privacy. Things like export controls are part of MIT's framework and institutional concern, and they have to business sensitivity, etc. We'll go into those in detail. So the other set of concepts that are pretty important for practically managing this around information security, and privacy and security overlap. And actually, it can be confusing because they use some of the same terminology. Confidentiality is a term in information security, means somewhat the same thing as we're using it to mean, but not exactly. Generally, providing information security, secrecy or confidentiality in that framework, basically controlling who can get to different pieces of information. Think of it as access control. That's pretty important because the information exists in the system in various different ways, and we may take we may put many controls on how we disseminate the information, but if someone can get at it while it's at rest in our systems, then those, then the confidentiality of the subjects is violated through a different channel. Right? So it's a prerequisite, but it's not sufficient. You can release things, you can have complete confidentiality in the information security sense, and still have all sorts of harms that come from the data release. And there also, you should note, just a general difference in analytic approach. And this is, broad categorizations, but privacy analysis tends to focus on high-level principles at the top, and then on sort of privacy utility trade-offs, harm utility trade-offs. Where information security analysis tends to focus on maintaining a set of security properties for information within an information system. So the different scope, different set of definitions, and the key properties in information security are things like confidentiality or secrecy, exposing information only to those who are authorized to get it, and that's important for us. And then there are things like integrity, which means that that information can't be altered, availability, authenticity, non-repudiation. These are mostly orthogonal concerns, but you want your information security system to have these. Here's a simple model of how an object is controlled within a standard information security system. There's some actor, which is known through authentication. There's some choice of getting at a resource. There's an access to the resource through some sort of interface. It may be direct, it may be a function over it. And there are log events that are now available. That's a sort of general framework. And a general framework for analysis, which we will not go into here, but we do in the class, is to look at what are the threats to the system, and those are intentional threats, people trying to force the system to not be secure, not have integrity, not have availability. It could be unintentional events, people pressing the wrong button, making mistakes, and because we're interested in information security and for things like availability, it could be natural events like fires. where is that vulnerability, where are the vulnerabilities that these threats might interact with. They could be in the system, they could be physical, they could be social engineering. And then how do we evaluate the risk and threats and apply sets of controls to mitigate those so that we preserve these security properties that we're interested in. So it's a nice framework, but sort of a limited scope. Right? And controls are generally either process, we can make people fill out forms, we can vet people, technical, or including auditing, encryption of transmission, enforceable policy frameworks, or, and information security doesn't look at these very much, but externally you can apply fines, you can give people the right to sue, etc. So that's the sort of concepts. What's the state of the practice? There are, when you're doing research, collecting data for research, there are a number of different stages that you need to think about confidential data management. You should start thinking about it at the collection point. So before you're doing the research, there are typically, if you're involved with humans, there are human subject plans. So you have to have some plan for collecting the data and for protecting the human subjects in it. This is for data. This is for research done within federally funded research institutions. So if this research is being done at McDonald's, they won't have to do this. But generally within, the scope that we're working at. And also these are increasingly accompanied with data management plans, which specifically say how the data will be managed both during the research and after. You need to think about consent and licensing terms. What legal agreements are you using, and how are you communicating with the data subjects or the data sources? Those consent and licensing involve both sort of the legal restrictions and communication events. What methods are you using to collect? How are you measuring? Then we store stuff in the system. We analyze it. This is, there are many more phases here, but kind of within an institutional boundary. Right? You're collecting data, you store it, you do some analysis. At some point, you disseminate it to the world, you publish something. IRBs have a role. IRBs are institutional review boards. They have, in some institutions, a general purview for limiting the harm from a particular set of research. That includes information privacy. Even if the IRB doesn't require it, one could think about reducing risks in data collection. And in some frameworks, this is called data minimization. I might call it good research design, to figure out what information are you collecting, what research questions, hypotheses, et cetera, you're trying to test, and how do you think those measures will enable you to test that? How do you expect to analyze it? What do you expect to see? Whether it's, whether the test is supported or not supported, what other diagnostics might you use. If you don't need information for that, and it has cost in terms of privacy, risk, et cetera, then you might think about not collecting that. And there are different sorts of techniques to do that. One is around the context of collection. One place where confidential information could be observed is during a collection event. And this has happened in research in sensitive areas. Right? Another is what's being collected. Do you even ask people what their age is, or do you give a bracket? Do you ask people if to have responses individually, or do you use some mechanism to collect all the responses from a subgroup? And so the researcher only sees the aggregated response. There are also things like randomized response techniques, list responses, where you might give a subject, instead of a survey of how many crimes did you commit, you would say, give us the sum total of the number of crimes you committed and the number of ice creams you had in the last year. And then if you can, if you know what the mean number of ice cream events is, then you can do some estimates based on that. But you don't have any extreme, specific revelation. Of course, there can be learning about individuals there that goes on from this data. but that's something that doesn't happen. So you might apply something similar at, a related technique at disclosure of this, but this is something that can be and is applied at collection in some sensitive data. And there are some variations in the real world, the ability to use anonymizing data collections, third parties to collect sensitive information if there's a trusted relationship, sort of you can prevent information from being transmitted, or sometimes you have to use not so trusted intermediaries like cloud surveys. You may think that you are not collecting individual IDs, but they're collecting IP numbers and they're logging this and it's subpoenable. So that, what is collected and what you intended to collect in the research design might differ when you go through third parties. And field research, which is a special concern for some of the folks at MIT, for example, where what you can do you have different sets of technical constraints, legal constraints, and very different changes in the risk and vulnerability surfaces. Different questions are sensitive, different releases are sensitive. And some not uncommon, not bad practices. I mean, this is nowhere near the state of the art, right? But this is sort of the state of the common not bad practice if someone's thinking about it. And it roughly corresponds actually to the Massachusetts personal privacy security controls that are part of the Massachusetts law. Do some analysis to detect what's sensitive, to identify things that are sensitive. Generally, this is procedural, right? Not sort of computational, but it could involve scanning in business areas for social security numbers, for names, for things that look like identifiable tokens, entities. Use encryption on stuff at rest, generally their whole disk or file system level, the media level encryption rather than file-based. And encryption in motion. Core information hygiene, I'll unpack that. And do some regular auditing, and when you get rid of this stuff, do it in a thoughtful way, in a controlled way, and we'll talk about information hygiene. I mean, maybe all of these things are obvious, but my experience with different researchers is that they're only obvious after they're explained. Especially things like destruction. What do you mean this stuff is still on my SSD? Another, a good practice, though more advanced, is partitioning information. This is sort of fairly standard in bigger studies, which is to segregate information that's identifying and information that is deemed to be particularly sensitive, and to use linking codes and to manage these in different security containers and have different people associated with it, so that even during the research, before some dissemination, even within the boundaries of a particular institution when it's managed, there is not, people do not uniformly get access to the entire corpus, right? It's the separation and management happens institutionally. And that's not too hard. There are some details like using linking keys that are either actually random or not guessable instead of two-way functions. So we've seen that before, but and then the state of the practice is to when you think about sharing this more broadly than the group that's performing the research on it, is to suppress stuff, is to mess up the data in some way. And you'll see a lot of these different techniques over from others. I tend to think of it as a set of transformations that get applied to the data for disclosure limitation. That could be adding noise. It can be removing observations or fields. It can be domain generalization, semantic generalization, where instead of neuroscientist, you put scientist. But there can be swapping of observations. There's this basic set of primitives for messing with the data. And you can mess with the data when it's in the microdata form and then release it, sort of static data publication. If you're in statistical agencies, they tend to do that after they have a crosstab. They make a crosstab and then try to perturb it, or on demand, just in time. You compute the answer that you want, and then apply something, typically noise, to perturb that. And the perturbations, the transformations, are based on some property of to satisfy some property. Like you're applying these because you don't want a record linkage, or you're applying these so that all records are indistinguishable up to, from two others, or you're applying these to satisfy a differential privacy concept. Right? So they're different, but they're modular. Right? You can take the same transformations, you can apply them at a different stage, you can use a different solution concept, and then how you present that, it may be that you're presenting the result as a model estimate, or information visualization based on that data, something else. And so here's an example of a friendly table of data with ice cream flavors and crimes. There are a few things wrong with it. I mean, some of them are pretty obvious, like the number of crimes committed might be sensitive. This might, in a HIPAA environment, this one might not be so good, right? They said they were allergic, which is the medical information now. Here it looks like you've discovered twins who are separated at birth, and does that raise ethical issues? These are from California, the California state, so the laws for California state residents may apply to you there. Here are mass residents. There are some people who are looked to be underage, so probably FERPA applies. So, one approach is to suppress the heck out of it, and that may help with respect to some of these standards. But as you can see, it's like and this is a faked example, but it starts to reduce the information on the data, and more important, the sort of analysis that you run on that are not just going to necessarily have bigger standard errors, but they're going to be biased in general, unless you're very careful. But R can do this, so this is not beyond the state of the practice. SPSS, Stata doesn't do this so much, a little bit of it, but R will do this, and we'll apply a lot of those methods and mess it up for you, so you can do that. So some note of caution, right? So the common approach of suppression and basically reduces the usefulness of the data, and it may, depending on what the external data you're worried about is, it may reduce the usefulness a lot. And it's not just that there's less information, and so you get larger standard errors, but you get an unbiased estimate of the same thing. But with some of these techniques, there's no guarantee that you won't get a biased estimate, that your inference, you will not be able to infer to the same population that you collected from. And there are many other things we could comment on, but I'll just talk about, very briefly, advancing the state of VR here. And one thing to think about is this cradle-to-grave analysis, rather than looking at just what happens at disclosure, or just what happens at retention. It's one of the things that we try to do in the project, is to look at these factors and how they interact, which is different from many from information security tends to look at the retention phase when it's in the system. When it goes out, no. A lot of the privacy controls tend to look at this at the dissemination stage. But these interplay. There are some neat overarching principles, and they're pretty good, but and there are quite a few of them, and they're very recognizable, but they don't really help very much in constructing solutions. Right? So you should think about the solutions you're constructing and whether they meet some of the high-level principles that a lot of the field and policymakers have sort of connected with, but you can rely on these to construct the solutions. There's quite a bit of interventions, and that huge, what was it, 30,000 word paper that we just sent around lists a sample of interventions at these different stages, and They can be procedural, economic, educational, legal, technical, including new methods of encryption, statistical methods, etc. And big data makes this, I mean, it might make it easier in some ways, but it also makes it harder in that things like suppression methods that were designed in the traditional statistical disclosure literature don't apply well to sparse data. Right? And any time we have long tail observations of human behavior, you get sparse data. So if you actually try to make sure that no Netflix set of ratings is unique, is distinguishable from any other one, you basically kill the tails of that data. Observable data leaves fingerprints when people travel, when they make credit card purchases. Those patterns are identified. If you have external information from another source, somebody publishes my jogging route, well then maybe you'll be able to match me based on my public jogging route in a restricted, quote, anonymized cell phone database. External, big data can be rich, messy, surprising. So we looked at, traditional methods are really focused around sort of removing tokens like names, or looking at values, means, categorical values, sometimes continuous values. You start to look at text. How do you anonymize a writing style? Right? It's not that it's necessarily impossible, but we don't know how to do that. And a danger comes in when a researcher is thinking about mining for topics, right? So the thing that they plan to measure is a topic, but the thing that they actually collect is this richer entity, which is prone to many other sorts of measures than they anticipated, which can leak information which they're not really thinking about in their research and design. And that creates a space for both, serendipitous learning. We can look at YouTube videos and figure out that people have Parkinson's, and violations of privacy for exactly the same context. And little data in a big world, right? So many of these techniques involve some assumptions about what auxiliary information is available, what information an attacker might have, and what information only you have, right? And the idea is to prevent that linking. Well, if I do a good job with that, and I publish my crimes and ice cream database, but then it's based on all the external information now available. It's completely protective. And now somebody publishes later, 3 years later, the favorite ice cream players database, which is not, and they may publish it, not anonymously because that's not high-risk data. Right? Well, now if you know I like Chicken Ripple, you probably got me in those other databases. And so little data doesn't stay, even little data doesn't stay in context, right? It moves into a big data context, and then there's all sorts of other information that can be leveraged. And finally, sometimes, increasingly these data systems and policy are being used to feed algorithms. And so they're incorporating lots of signals, many that weren't even intended to be collected. So you may have, as Latanya's work showed, sort of racially biased ad delivery, not because either the designer of the algorithm or the vendor designed it that way, or even because probably people were acting with racial animus, but because people were more likely to click on certain ads with certain combinations in there, because they have some unconscious or implicit biases there. But the algorithm may focus that and may use it for different decisions or in a different context. And nobody plans it that way, and unless you are explicitly looking for those sorts of effects, you're not going to find them in a big data world, right, with this rich, messy, large stuff. So some overall takeaways. It's think about confidentiality as learning, principles are good, but they don't provide enough guidance to construct things. Big data changes, and you've got to look at the private security risk controls, accountability over the life cycle. So all this is on the informatics program website, papers, slides, all that sort of stuff. And I'm always happy. I come to most of the all hands meetings except when I'm traveling, and I'm happy to answer emails, etc. Questions?
I have a question that I thought of, but I don't know if it's like, I don't know if it's a good question, but
Well, it's
I'll
probably a
ask it.
dumb
Oh.
question, but ask it anyway.
So what if you encrypt data and then you do it in such a way where you're swapping information, let's say, and then you end up identifying like the wrong people? Has that ever been thought of? Like, or if you remove data and then you're like pinpointing like general populations, and then like assumptions are made about like incorrect people, or like the learning gets skewed because of that.
So this is a really interesting question. I mean, in some of the literature, this is talked about as does a statistical data limitation technique preserve realism, right? In that the things that when you look at a record, are the characteristics of that record true? And changing neuroscientists to scientists preserves their realism, but swapping pieces of records does not, right? And so that's a concern. It's not recognized across all literatures, but there is a concern for this realism in some of these methods. And then there's a real question, which is we've talked about somewhat in the group, but I have never seen analyzed systematically, which is what are the inferential purposes, right? You're collecting data. Are you intending? What do you use the data for? You could use the data to make inferences to the same person in a different context, right? You could make it to infer to similar individuals, right? You could use it to infer groups. You could to the population, to some hyperpopulation, how the world works, and you could do that for different purposes, either to describe them, to predict what they're going to do if you don't, all other things equal, or to actually to intervene with them to change their behavior, or to understand a previous event and why that occurred. And so there's some sense, I think, in which different techniques affect these sorts of inferences differently. And that's one example of this realism. If you're trying to infer to that same individual's behavior, predict that. But there's no systematic framework for understanding that.
So the applied side is really interesting, and on that the last point you made about the racial bias amplification, that is pretty, it's conceivable how it happened. Is there a popular example of that happening in the world yet? At the last bit where you said the algorithms could accidentally... Oh, yeah,
Google AdWords.
Oh, yeah?
Yes. Google, if you read LaTonya Sweeney's article, Communication ACM, on online ad delivery, I think bias in online ad delivery, describes cases where, because of the auctioning algorithm used for AdWords, a vendor bought a list of last names, and it meant to be comprehensive, to place ads for criminal background searches, right? Because of people's click behavior, those ads evolved to be presented only when those last names were paired with black first names. So what was getting served for these criminal background check ads was racially biased, but that was not probably wasn't the intent of someone who clicked to understand that's a small event. It wasn't the vendor, and it sort of wasn't the algorithm. There's another part of that, which is that the whole that whole ad delivery mechanism was based on a sort of semi-blackmail scheme where people would suck up all of the arrest photos from various county databases and then make it easy to find and then have you pay to remove them. But that's a different principle about the information staying local. that was not part of the algorithmic discrimination valence of that. But how public information previously could be public in at the county courthouse in Mississippi from 2 to 4 on Thursdays if you go and you pay $5 to get a copy of it. And now that little data doesn't stay there, right? Doesn't stay in Vegas. Other questions? All right, well, questions later.
Thanks, Micah. All right, so first an apology for coming in late. For any of you who are having a hard time navigating around campus, you need not feel bad. I've been here for a long time, and I was sitting in the room across the street. So these two buildings are, I guess, mirror images of each other in many ways. And 354 happens to be a conference room there. And I just went upstairs from the Dataverse community meeting. I was like, oh, you know, I'll just wait here for people to show up. And no one
We were
came.
waiting in 262.
Downstairs,
Yeah.
here. Yeah.
That building's the evil twin.
Second, I need to borrow, so Windows is stuck at 81% of installing updates. Bad idea to click OK, install updates before you're giving a talk. Does anyone have one with, I guess just need a web browser to get my slides and PowerPoint installed.
Yeah, I can.
Thank you, Kobe. All right, so I think we should also do another round of introductions, but maybe let's do that at the beginning of lunch. Oh, did you do one
did.
today? Oh, great. All right, they're all ahead of me.
You need to use this.
Thank you.
One of those two. Oh, we're still maxing.
I don't know if I'm Yeah, just close this window.
Here, I can move this plug over here.
Okay.